We are group number 3. This is proposal number 2, and I'm Taylor Jorgensen.
I'm Tony Christensen.
I'm Mark Hall.
I'm Christy Hornland.
I'm Hao Tran.
The purpose of our BI system is to track inventory fluctuations and to monitor shipments from suppliers. The measurement events are when food is sold, spoiled, or lost, and when shipments arrive from vendors. Managers are interested in efficiency with their food and vendor reliability in terms of timing and quality. The business process being supported by this system will be the monitoring of inventory for a franchise restaurant and monitoring shipping from various suppliers. The business process can fall under the category of inventory management, as the key fact records will be the inventory levels for certain years, quarters, months, and all the way down to current date time, as well as shipping information over time. The client wishes to have a system that can track inventory to make forecasting more reliable, to ensure timely shipments of ingredients, and to decrease unnecessary spoilage. The data sources that already exist simply require our team to turn their raw data into a usable competitive advantage to ensure quality without unnecessary loss or excess cost.
Our BI system for a restaurant franchise has 2 fact tables. We have inventory fact and shipment fact for the system. Starting with inventory fact, we are looking at the grain of inventory measures of a specific raw material item for a certain restaurant and date. As you can see, we have some examples of data that would populate this table. Inventory ID will be specific to raw material item associated with a particular restaurant ID. Every time an inventory item is checked, the date will be recorded as well. The defect type is broken down into 0 for no defects, 1 for spoiled, and 2 for lost inventory. The cost associated with each item will also be recorded. Elapsed time in days is recorded to later be used to compare the average shelf life of a product. Inventory fact will allow us to examine inventory at different periods of times and the rate of defects. Secondly, shipment fact looks at the grain of a shipment order from a vendor arriving on a certain date at a certain restaurant. Vendor and restaurant are able to have a hierarchy of location, and order ID will be associated with vendor ID hierarchy as well for later use. Rejected order list 0 or 1, where 0 is an accepted order while 1 is rejected. Tardiness of an order is recorded in the next column by day. Order ID is recorded, which will be associated with a particular vendor for later analysis. And the arrival date of a shipment will be recorded along with order defects as 0, which is for none, 1 for spoiled, 2 for incorrect contents, or 3 for incorrect quantity. This will allow for enhanced vendor relationship management and a better understanding of shipment accuracy and timeliness.
Let's take a look at some of the dimensions in our BI system. First, we have date time. This answers the when portion of our dimensions. Our hierarchy is built upon date time, which folds back into week, which are 52 in a year, which folds back into a month, which we have 12 of, which folds back into a quarter, which we have 4 of, and then finally a year. Some of the cardinality values include date time, which would just be any date of a month of a year plus the time. Week would just be 1, 2, or 3, and so on and so forth. Month would be 1 through 12. Quarter would be 1 through 4, and year would just be any year value. Attributes given for the dimensions are date time, which is a primary key that makes up dim date time. Week is a primary key, which makes up dim week. Month, primary key of dim month. Quarter, primary key of dim quarter. And finally year, which is a primary key of dim year. Our next dimension is restaurant. The hierarchy for restaurant is restaurant, which we have 27 of, which lie in 10 cities, in 5 counties, in 4 states, and in 2 regions. Example cardinality values include for the restaurant something like Eastside Grill, Joe's Steakhouse, or the Smokehouse. Our cities would be Seattle, Portland, or San Francisco. Counties would be formatted like King, Orange, or Whitman. States would be the 2-letter code of CA for California, WA for Washington, OR for Oregon, CO for Colorado. Region examples would include Pacific Coast and Rocky Mountains. Following attributes make up dim restaurant. Restaurant would be primary key, and then restaurant name would be another attribute. For dim city, the city ID would be the primary key, and then we would also include the city name. For dim county, we'd include county ID, which would be the primary key, and then county name. For dim state, we'd include state ID, the primary key, and state name. For dim region, we have region ID, which would be the primary key, and then region name. For inventory item, we have a hierarchy of inventory item, which currently rests about 786 inventory items, which that would make up a prepped item. Finally, a prepped item or more would make up a menu item. Cardinality values include 2% milk, eggs, and pepper jack cheese for inventory item. For prepped item, we'd have something like cheese sauce, browning sauce, or prepared meat. And finally, for a menu item, we'd include 16-ounce ribeye steak or chef salad, or something like potato rolls. Attributes for dim inventory item include inventory ID, which is the primary key, and then the inventory name. For dim prepped item, we'd have prepped ID, which would be the primary key, prepped name. And finally, for dim menu item, we'd have menu item ID, which is the primary key, and then menu item name. Our last dimension would be order. We have a hierarchy of all the orders, which fold back into specific vendors. Cardinality values include order, which is B 1, 2, 3, and so on and so forth. And then for vendor, we'd include AJ's Produce, Top Notch Noodles, American Steak Incorporated, and other of the like. Attributes for dim order would just include the order ID, which is a primary key. Dim vendor would have vendor ID, which is the primary key, and then the vendor name.
All right, now we'll take a look at some of our fact measures and calculated measures. We have two fact tables, inventory fact and shipment fact. So for our fact measures for our inventory fact, we got three separate ones. We've got defects, which is going to identify whether or not an item has a specific defect. We're going to have cost, which is just cost per item. And then we're also going to have elapsed time in inventory, which will display how long an item has been in inventory. And also for our inventory fact, we got three calculated measures. The first one is percent of rejected products. This will be a calculation of total defects over total inventory. The second, cost of rejected products, will be calculated by total defects times the cost, which is cost of the rejected products as a total. Our third calculated measure will be overstock. This will be calculated in this way. We will sort all the items that have spoiled, compare their time in inventory that it takes for them to spoil, and then if it's greater than a certain threshold, we'll leave a note that it's overstocked for that item. For our shipment facts, fact measures, we have three. The first, order defects, which is just the type of defect associated with the shipment. Rejected orders, which will measure the total number of rejected orders. And tardiness, which will count the total days that that order is tardy. For our calculated measures for shipment fact, we will have four. The first, percentage shipments on time, which will be a calculation of the total number of shipments on time over the total number of shipments. Our second will be percentage shipments rejected, which will be a calculation of the total number of shipments rejected over the total number of shipments. We will have an order defect rate, which will be a calculation that starts with sorting by defect type. Then we will divide that particular count by the total defects. Our fourth, vendor accountability, will be a calculation of the total of all the days in the tardiness column divided by the total days in a year to see the average tardiness from a vendor in 1 year.
Okay, so these are our logical tables for inventory fact. Restaurant ID, date time ID, and inventory ID are composed of the primary key for the inventory fact table. Defects, costs, and elapsed time in inventory will be measures in this table. Along with this, we have date time connected to inventory fact. Now this will be present in our other fact table as well. Another table we have is dim restaurant. Here we have our restaurant ID, which will be connected to our inventory fact table. The dim restaurant and dim date time will both be present in both fact tables. Lastly, we have dim inventory. Now this is for the inventory name and prepped ID, and it goes deeper to talk about the inventory items in the inventory fact table. Our second fact table is shipment fact. Shipment fact is comprised of date time ID, restaurant ID, and order ID as primary keys. The measures we're looking for here are accepted orders, rejected orders, and tardiness. So we already talked about the date time table and the restaurant table that will also be used to connect with shipment fact. The last one that will be connected to shipment fact is dim order, which will collect information about the order and vendors. Lastly, we have the physical schema for inventory fact. Here you see all the connections here. Dim date time, dim restaurant, and dim inventory, all connected to inventory fact, and you can see they're following hierarchies. And lastly, we have shipment fact, and you can see dim date time, dim restaurant, and dim order connected to shipment fact.